Welcome to The Explainer. We're here to break down big, complex topics into something you can really wrap your head around.
So, get this. How is it possible for one single animal to father, literally, tens of thousands of babies all over the world? It sounds like something out of a sci-fi movie, right? Well, it's a reality in modern agriculture, and it's all thanks to one seriously powerful technology.
And that technology is artificial insemination. You'll often hear it called AI for short. And believe me, it has completely changed the game for animal breeding. And because of that, it's changed the food that ends up on all of our tables. And we're not talking about some niche fringe practice here. I mean, look at these numbers. For dairy cattle, it's around 80%. For pigs, we're talking over 90%. And for turkeys, it's pretty much 100%. This science is the backbone of so much of the world's milk, pork, and poultry.
Now, the advantages are huge. You can take the best genetics from one superior animal and use them everywhere. It's also a great tool for controlling the spread of disease. But it's not without its risks. For instance, some males can carry and spread viruses without ever showing symptoms. They're known as shedders. So the whole process has to be managed with incredible care.
So that brings up a pretty important question. With the stakes this high, how do scientists make sure they're getting it right? How do they guarantee only the best of the best genetics are passed on? Well, let's dive in. It all starts at the microscopic level, with what is basically a sperm Olympics. You heard me right. Before any sample can even be considered, it goes through what you can think of as a microscopic job interview. It has to pass an unbelievably rigorous series of tests. So every single sample is put under the microscope and judged on these super strict standards. First, concentration. We're talking more than 500 million sperm in a single milliliter. Then motility. At least half of them have to be strong swimmers moving forward. And finally, morphology, their physical shape. Over 80% have to be normally shaped. If a sample fails on any one of these, it's out, no exceptions. And of course, there's a whole scientific language for this stuff. If a sample has 0 sperm, that's called azospermia. If there's a really high percentage of abnormally shaped sperm, that's teratozospermia. It's the specific vocabulary of fertility science. And this slide just shows it so clearly. Look at the difference in motility. On the left, those are your star athletes. They're moving forward, leaving those clear tracks. They know where they're going. But on the right, those guys are just swimming in circles. That's a huge red flag, and it's often caused by something like cold shock. And then comes that final inspection, morphology. I mean, just look at all the ways a sperm can be considered abnormal. The defects can be in the head. Maybe it's too small or tapered, or you can even have, get this, double heads. No, this isn't just about looking perfect. That 20% number is absolutely critical. If a sample has more than 20% abnormal sperm, the chances of a successful pregnancy start to plummet. It's a direct link. Okay, so a sample has passed the microscopic job interview. It's the best of the best. What happens next? Well, now we have to figure out how to collect it and store it for the long haul. So how do they collect it? They do it safely and efficiently, using a device called an artificial vagina. And it's actually pretty cleverly designed. It uses warm water to create the perfect temperature and pressure to simulate natural conditions, which makes the whole process work. As soon as it's collected and gets one last quality check, the sample is immediately processed. A special fluid called an extender gets added in. You can think of it like a nutrient-packed smoothie that also protects the sperm. Then the whole mix is packaged up and ready for a very, very long nap. It all gets packaged into these thin plastic straws, and each one holds a single dose. Then they're put into these special liquid nitrogen tanks at an unbelievable minus 320 degrees Fahrenheit. To put that in perspective, that is colder than the surface of Mars. And in there, they can stay viable basically forever. All right, we've covered the intense quality control and the incredible deep freeze preservation. Now we get to the final mile, the part where all this science is actually put into practice. For cattle, the most common way this is done is using the rectovaginal technique. As you can see from this diagram, it allows a trained technician to actually use one hand to guide the insemination gun through the cervix, making sure that semen gets deposited in exactly the right spot for the best chance of success. And the procedure itself is all about precision. First, the frozen straw is thawed very carefully in a warm water bath. Then it's loaded into the insemination gun.
And this is where the real skill comes in, carefully guiding that gun through the cervix to deposit the semen. It really takes a deep understanding of anatomy and a very steady hand.
But wait, the technology doesn't just stop there. We're now at a point where the cutting edge of AI allows producers to choose the sex of the offspring before conception even happens. Yeah, this is where things start to feel really futuristic. So how on earth is that possible? It's all thanks to a remarkable process called flow cytometry. And the whole thing works by exploiting one tiny, brilliant biological fact. Female-producing sperm carry just a little bit more DNA than male-producing sperm. And there's the magic number, 3.8%. That's it. The female sperm, the one with the X chromosome, has just 3.8% more DNA than the male sperm with the Y. It sounds impossibly small, doesn't it? But it's enough for a laser to tell the difference. And here's how they do it. All the sperm gets stained with a fluorescent dye that sticks to DNA. Then they're sent single file past a laser beam. Since the female sperm have a bit more DNA, they've soaked up more dye, so they glow just a little bit brighter when the laser hits them. The machine detects that extra brightness, gives them a tiny electrical charge, and sorts them into different streams. This process is about 90% accurate. Just imagine what that means for a dairy farmer who only wants female, milk-producing cows. So there you have it. We've gone from that one elite animal we started with all the way to designing entire herds with pre-selected traits. It's all possible because of this incredible scientific process, from the microscopic quality control to the deep freeze tanks and the laser-guided sorting. It really is a technology that's constantly evolving and pushing the boundaries of what's possible in genetic selection.